It was Ralph Waldo Emerson who said, "A man builds a fine house, and now he has a master, and a task for life. He's to furnish, watch, show it, and keep it in repair the rest of his days." In this lesson, we're going to find the missing sides of right triangles using the Pythagorean theorem. We're going to use the converse of the Pythagorean theorem. We're going to find the slope of a line. We will describe the proportions in similar triangles. We're going to find the missing sides of right triangles using trigonometry, and we're going to find missing angles in right triangles using inverse trigonometric functions. All to answer the question, how do you maintain your property? Before we begin, let's make sure we're ready for this by looking at warm-up number 2. A class of 20 students averaged 81 on a test taken yesterday. One student was absent. He takes the test today and scores a 98. What is the average of the class with the student included, and round to the nearest integer? Now the thing is, the average that we know was 81, and this was out of 20. If we were to just act like all 81 grades were made by all 20 students and add to that the 98 that we just got and know there's 21 students, then we would have 1718 divided by 21, which would give us 81.8, or approximately an 82%. Now, let's take a look at a problem that you will be able to do by the end of this lesson. The Americans with Disabilities Act, or ADA, states that ramps for wheelchairs should have a slope of 1/12 or less. What does the angle of elevation of a ramp have to be to get ADA approval? So we're going to draw a diagram that shows 1/12, meaning that it is 12 long and 1 high. What we're trying to find is this missing angle. Notice that the given rise and run are the sides of the opposite and adjacent sides of a right triangle. Therefore, this problem involves the tangent. However, in this case, angle A is not given. You can use the inverse trigonometric function to find the missing angles. Inverse trig functions are indicated on your calculator with a little -1 exponent. Since the problem involves the tangent, we're going to use the tan inverse to find this. So the tangent of the angle is going to be equal to 1/12. But we're going to take the inverse, meaning the angle is going to be equal to the tan inverse of 1/12. Now we can put this into the calculator with a fraction of 1/12. Hit the second button to get the inverse, and what we get is that the angle is approximately 4.8 degrees. Most homeowners will live in their homes for many years, often a few decades. Take a careful look around your home. Imagine the financial investment in purchasing and maintaining everything in your home. Think of everything about your home that needs upkeep. Lawn, plants, shrubs, and bushes, the roof, windows, doors, siding, the garage, the electrical system, the basement, sprinklers if you have them, plumbing, walls and floors, appliances, bathroom fixtures, lighting fixtures, home entertainment system, furniture, and an alarm system. Knowing how to keep your home maintained is important for your comfort and safety. It also helps you to enjoy the most expensive purchase you will ever make in your lifetime. Sometimes homeowners can do the repairs themselves, and sometimes they need to hire a professional. In either case, the working knowledge of geometry is extremely helpful. This includes the area, perimeter, and volume, which we learned about in the lesson on reading a floor plan, and other helpful concepts you learned in this entire unit. Your knowledge about home maintenance and improvement will help you save money and spend your money wisely. Many home maintenance and repairs require you to measure tall heights from the ground. Cleaning rain gutters, trimming trees, and hanging holiday lights are just a few examples. Whenever you're using a ladder, you're forming a right triangle. A ladder needs to be set up at a correct slope, otherwise it can be dangerous to use. The slope describes how slanted or steep the ladder is. You first learned about slope in early algebra classes. A homeowner needs to know how measurements in triangles can assist them in maintaining their home. The field of mathematics that involves measurements in triangles is called trigonometry. Now let's find missing sides of right triangles using the Pythagorean theorem. Anna is planning to build a 15-foot by 20-foot rectangular deck off the rear of her house. She's going to put stakes at the corners of the plot and lay string from stake to stake. She wants to make sure she has a perfect right triangle to start. How can she do this? Now, Anna can use the Pythagorean theorem, which says that a right triangle with sides A, B, and C will give us a squared plus b squared is equal to c squared. The converse of the Pythagorean theorem says that if a triangle with sides A, B, and C have the relationship that a squared plus b squared equals c squared holds, then the triangle is a right triangle. Anna uses this fact and goes to the corner of her house at C and marks off 5 feet along the house as shown in the diagram. She then has a friend hold a 12-foot piece of string stretching from the right side of the house perpendicular to the rear of the house as shown. Both of these segments are legs of the right triangle that we're trying to create. So if a squared plus b squared is equal to c squared, then we can have 12 squared plus 5 squared should be equal to c squared. This means 25 plus 144 will equal 169 for c squared, or c will equal 13. So Anna's son cuts a 13-foot long piece of string, and Anna holds it at A. Anna's friend holds the 12-foot string and moves until it exactly meets the 13-foot long piece of string that Anna's son is holding. When the 13-foot piece of string and the 12-foot piece meet, a right angle is formed at C, and they can start laying out the deck. To measure 15 by 20. The side opposite the right angle is called the hypotenuse. Let's check our understanding of this. If Anna measured 6 feet along the house and her friend held an 8-foot long piece of string at a right angle, how long would the hypotenuse be? So we'd have an a squared plus b squared equals c squared because we're after a right triangle. This means we're looking at 6 squared plus 8 squared is equal to c squared. So we would wind up with 36 plus 64 to get 100 is c squared, or c is 10. Let's extend our understanding a little farther. When Anna's 15-foot by 20-foot deck is fully plotted, she wants to double check all of her angles to make sure she has a rectangle. The opposite sides are congruent, but parallelograms are not rectangles, also have opposite sides congruent. The only parallelogram with congruent diagonals is a rectangle. She checks both her diagonals to figure if the mark is truly a rectangle. What is the length of the diagonal? So we know we have a rectangle with 20 by 15, or at least this is what we're going after. So we can say 20 squared plus 15 squared will equal c squared. This will give us 625 is equal to c squared. If we take the square root of 625, we find that c is 25 feet. Now, let's find the slope of a line. Manny's hiring a roofer to do some work on his home. The steepness of the roof will affect the labor cost that he's charged. Below is a side view of Manny's roof. How can he mathematically describe the steepness? Now, Manny can use the slope, which is also called the pitch of a roof. Roofers use the term pitch, while mathematicians use the term slope. Slope can be defined by using the terms rise and run, as shown in the diagram that slope m is equal to the change in rise over the change in run. The rise and run can be measured anywhere along the line where you're finding the slope. Manny finds these measurements, that the rise is 12 from the very top, and from that point all the way to the edge, we get an 18. This means he has a slope of 12 over 18, which is 2 over 3. The pitch or slope of Manny's roof is 2 over 3. Let's check our understanding of this. A steep roof of a Victorian house has a rise of 19 feet and a run of 12 feet. Is the pitch greater than or less than 1? Well, we understand that it has a rise of 19 feet, a run of 12 feet. So this means we would do 19 over 12. Now, 19 is larger than 12, so we know that this is greater than 1. Let's extend our understanding a little farther. If you're graphing a line in the XY coordinate plane, the formula for slope between 2 points is shown here on the screen. Find the slope of the line that passes through 7, 4, and 11, negative 20. This means we would be looking at a negative 20 minus a 4. Those are our y coordinates. Now that would be over 11 minus 7. This would give us negative 24 over 4. When simplified, that would give us a negative 6. Now let's describe properties in similar triangles. Noah has a tree in his backyard and he wants to make sure that it cannot fall on his house if there is a bad storm. The tree is 52 feet from his house. How can he find the height of the tree? So we know that he's 52 feet away from his house and it would require a tree being at least T tall. Noah must first create a scale model of the position of his house and the tree. He takes a photograph of the entire area in question and then draws a large right triangle on the far right. He then measures the distance on the photograph to create a perfect scale drawing shown on this second picture. He then measures the distance on the photograph to create a perfect scale drawing, which is now shown. The scale drawing is a right triangle. Since the actual measurements are a proportional enlargement of the right triangle in the photograph, the two triangles are similar. Similar triangles have their corresponding sides in proportion. Recall that when two ratios are set equal to each other, the proportion is formed. So we can look at the height of the tree in the photo over the height of the tree in real life is equal to the ground distance in the photo over the ground distance in real life. One leg represents the ground and it shows 5.5. This is the ground distance in the photo. Now the ground distance in real life is 52. One leg represents the ground, shows 5.5 centimeters between the tree and the house. The other leg represents the height of the tree, representing 6.2 centimeters. So we can set up to where we have 5.5 over 52 would be equal to 6.2 over t, our unknown height. In this proportion, 6.2 and 52 are called means, and t and 5.5 are called extremes. To find this proportion, we're simply going to solve for t by doing 5.5 times t is equal to 6.2 times 52, and then dividing both sides by 5.5 to get 6.2 times 52 divided by 5.5. This is going to give us t is 58.6. The height of the tree is approximately 58.6 feet. Since the distance from the tree to the house is 52 feet, if the tree falls, it could hit the house. Let's check our understanding. Riley parked his car on the driveway 34 feet from the base of a utility pole. If the pole snapped at the base and fell, could it hit the car? We know that the car is 34 feet away from the pole, and the pole is X high. Now, the picture shows that it's 3 inches away and 2.75 inches high. Now, I like to think of setting up my proportions as something like small over large. This is just a shorthand way to think of it. So I could do 2.75 over X is equal to 3 over 34. This means that 2.75 times 34 divided by 3 will give me my height of X. This will give me approximately 31.2 feet. So the car is far enough away from the pole that it won't hit if it drops. Let's extend our understanding of this. If two triangles are similar to each other, the corresponding sides are in proportion, and the 3 angles of one triangle are congruent to the 3 angles of the other triangle. Can you tell which sides are corresponding sides, since the corresponding sides are opposite congruent angles? Use the factors to find the X side angle, and the following similar triangles are not color-coded because of how this is. We're going to use the factors to find X. Well, the side opposite A is 21 here, and X here. So we're going to call this the large triangle and this the small triangle. So let's do small over large. This means that I'm going to wind up with 21 over X. The side opposite of B in the large is 38, and the side opposite B in the small is 19. So X would be equal to 21 times 38 divided by 19. So X is equal to 42. Let's use the converse of the Pythagorean theorem. Jessica is purchasing a ladder so she can save money and clean her own gutters. She needs to find the height of her two-story house to make sure she's buying a ladder long enough. How high are her gutters? So Jessica draws right triangles. Then she walks 12 feet from her house and measures the angle of elevation to the gutter. The angle of elevation is the number of degrees from the horizontal. Jessica must lift her eyes to see the gutter. To find this angle, she uses an inexpensive angle measurement tool called a clinometer. You can learn how to make your own clinometer using ordinary household items by searching this out on the internet. The angle of elevation to the gutter is 66 degrees. Jessica uses trigonometry and similar triangles to find the height. Look at the following four similar right triangles. The longest side is always called the hypotenuse. Each leg can be classified as the opposite leg or adjacent leg, depending on its position. BC is the opposite leg with respect to angle A. AC is the opposite leg with respect to angle B. BC is the adjacent leg with respect to angle B, and AC is the adjacent leg with respect to angle A. Look at the ratio opposite over adjacent with respect to angle A. In all triangles, the ratio is the same, 4 over 3. The ratio of the opposite side to the adjacent side is called the tangent, abbreviated tan. For any angle, this ratio can be found using the tangent key on your calculator. So look at the ratio opposite over hypotenuse with respect to angle A. In all the triangles, the ratio is 4 over 5. The ratio of the opposite side of the hypotenuse is called the sine, abbreviated SIN. For any angle, the ratio can be found using this key on the calculator. Now look at the ratio adjacent over hypotenuse with respect to angle A. In all of the triangles, the ratio is the same, 4 over 5. The ratio of the adjacent side to the hypotenuse is called the cosine, abbreviated COS. For any angle, this ratio can be found using the cosine key on your calculator. To find the height of the gutters, Jessica needs the side opposite angle A, and it's easy for her to measure along the ground to the foot of the ladder, which is segment AK. These two sides tell her she needs to use the tangent ratio. So with the tangent of the angle being the opposite over the adjacent, then we can say that the tangent of 66 degrees is equal to the height divided by 12. This means that 12 times the tangent of 66 degrees will give her the height. So if we were using a TI 30XA, we could say 66 tan times 12 equals. This is going to give her a height of approximately 27 feet. Let's check our understanding. How long must the ladder be to reach the gutter a 66-degree angle and round to the nearest foot? Now, we already know from the example that it's a 27-foot height, but they don't sell ladders on individual feet, so we're going to wind up with a 30-foot ladder. Let's find the missing side of a right triangle using trigonometry. Nabil completed the reality check problem 5 and built a clinometer. He wants to find the height of a tree that is on level ground in his backyard. He uses a tape measure and his clinometer to create the following diagram. How high is the tree? Well, the tangent of 51 degrees is equal to the height of the tree, t, divided by 28. This means that 28 times the tangent of 51 degrees will give us the height of the tree. So, trusting that 30XSA from Texas Instruments, we're going to say 51 tangent times 28 equals, and we're going to get 34.6. Or we could just call this roughly 35 feet. He then had his sister mark the tree at the point where the clinometer shows at the angle elevation of 0 degrees. He measured the distance on the ground to mark the tree. This is about 6 feet, which is approximately Nabil's height. So Nabil added 6 feet to 35 degrees to get a 41-foot tall tree. Let's check our understanding here. Juan, who is 5 3/4 feet tall, is standing 90 feet from the base of an apartment building, and the angle of elevation to the top of the building is 62 degrees. How high is the building to the nearest foot? This means we know we have 62 degrees looking up. We also know that we have 5.75 feet at the base that we're going to be adding on. It's 90 feet away. So the tangent of 62 degrees will be equal to x over 90, meaning 90 times the tangent of 62 is going to give us our height before adding in Juan's height himself. 62 tan times 90 is going to give us a number, and that number is 169.27. But if we add the 5.75, we get 175.02, or 175 feet. Let's extend our understanding here. Stacy wants to measure the height of a tall building in her city. She needs to walk several blocks from the building to get a clear view. What happens to the angle of elevation of the top of the building as she walks farther away from it? Well, we need to understand if she was standing very close to the building, she would be looking very, very high up. But as she walks away, that angle would decrease. It would get smaller and smaller. Let's find the missing angle in triangles using trigonometric functions. The Americans with Disabilities Act, or ADA, states that ramps for wheelchairs should have a slope of 1/12 or less. What does the angle of elevation of a ramp have to be to get ADA approval? So we're going to draw a diagram that shows 1/12, meaning that it is 12 long and 1 high. What we're trying to find is this missing angle. Notice that the given rise and run are the sides of the opposite and adjacent sides of a right triangle. Therefore, this problem involves the tangent. However, in this case, angle A is not given. You can use the inverse trigonometric function to find the missing angles. Inverse trig functions are indicated on your calculator with a little -1 exponent. Since the problem involves the tangent, we're going to use the tan inverse to find this. So the tangent of the angle is going to be equal to 1/12. But we're going to take the inverse, meaning the angle is going to be equal to the tan inverse of 1/12. Now we can put this into the calculator with a fraction of 1/12. Hit the second button to get the inverse, and what we get is that the angle is approximately 4.8 degrees. Let's check our understanding here. Rob has a 7-foot long piece of wood he used to roll heavy items into his van. The floor of the van is 2 feet off the ground. What is the angle of elevation of the ramp when it is being used to load items into the van? And we can round this to the nearest degree. So we know that it is 2 feet off the ground and that it is 7 feet long. What we do not know is the angle inside. So the tangent of the angle is equal to 2/7, or the angle is equal to the tangent inverse of 2/7. This means we can do 2/7 as a fraction, hit the second button to get the tangent inverse. That's going to give us approximately 16 degrees.